set theory. Let's say this one now should be part 3, so you can still look out for part 1 and part 2 to get more details. We want to look at universal set. This is the set which contains all the elements under discussion. Then we also have what we call complement of a set. This is a set which contains all those elements in the universal set that is not in its subsets. Let me take example. Now, before I forget, there's a symbol for universal set is big U. That's a symbol for universal set. Now let's take example. Assuming I can use anything for universal set. I can look at, let me say that my universal set has these elements 1, 1, 2, 3, 4, 5, 6. Now before I go further, you cannot talk about complement of a set if there is no universal set. It's only discussed when we're talking about when there's a universal set, if we can talk about complement of a set. Now, let's say that this universal set has subsets. Let me call it subset A. Subsets. We'll call subset in part 2 of this video. Let's say I have something like 1, 3, 5, for instance, as a subset of this universal set. Now, if you ask me to what is A complement? A complement. That is this subset A. What is this complement? Now, like I said, you can't talk about complement. There's no universal set. So, and this complement has symbols. Before I forget, something like this, on top. Some will use C. They put small c on top. A complement. Now, if somebody asks me now, find A complement. Find A complement. So my A complement, let me use the symbol that is. My A complement will be all those elements that are in universal sets that are not in my subset A become my A complement. So the answer will be, I will check, I have 1, I don't have 2, so 2 is one of them. I don't have 4, 4 is one of them. I don't have 6. So this is now my A complement. Remember that this A is a subset of the universal set U. Now let's say, for instance, I still have another subset B, for instance, and that B happens to be a subset of the universal set, and it contains 2, 3, 5, 6. Now if you ask me to find B complements, I will look for those ones that are in the universal set that are not in the subset B. And look at it, I have 1. 1 is there. What else do I have? 4. So that means my B complement is 1 and 4. That's my B complement. Like I said, you cannot talk about complement of a set. There's no universal. Because universal set is what will help you to answer any questions that has to do with complement of a set. Now let's take another example. We're talking about universal sets and A complements and so on. Universal set U has members A, B, C, D, E, F, G, H. Has subset A, C, D, E, and subset B, A, C, E. A, C, E. Okay, let me add something else to make it more interesting. ACF, for instance. You're asked to find, number 1, A intersection B. Number 2, A union B. Number 3, A intersection B complement. And 4, A union B complement. Let's start from number 1. Number 1, solution. A intersection B. That means all the things that are in A that are also in B. What are the things? A is here, A is here, C is here, C is here. But D is here, it's not here. E is here, it's not here. F is here, but it's not here. So A intersection B is simply AC. AC. Then question number 2 says, find A union B. A union B are all the elements that are in A that are also in B. A union B. So you have A union B. What will it be? Let's check. A, remember that you don't repeat any member. You have A is here, so I will take A. C is here, I will take C. Okay, let me create the space here so I can enter very well. A, I'll collect C. I'll also collect D. I'll also have E. I also have F. Notice that we did not collect A 2 times. One A is enough. C, D, E, F. So this is A union B. Then the third question is A intersection B complement. So complement can be like this or small c. So you go back to the first one. That's the solution now. For clarity's sake, so you know what we're doing here. Okay, you go back to this number 3, A and B complement. You go back to the answer. Answer here is AC. Alright? That means A and B complement, A intersection B complement will be all those elements that are in A intersection B that are not in the universal set. So what we have is AC as what is in A intersection B. So what else is not there? So we now have D is there, but not here. C is there, we should not take C. D is there, we take D. We take E, we take F, we take G. So this is A intersection B complement. That is those things that are in intersection B that are not in the universal set. Okay? So if you're given a question like this, if you're not given to solve this, before you can solve this, it's good for you to first of all get A and B before you can find the complement. It will be easier for you to do it like that. Okay? Then the third one is A union B complement. A union B complement. So go back to A union B is A, C, D, E, F. All those things that are in A union B that are not in the universal set. So we have A will not take it. We have C is here. But we don't have B here. So B is number 1. What else do we have? We have E, F. We don't have G. G is there. Let's check another thing. A, B. I'm taking B. We have D. We have E. We have F. The only thing missing there that we don't have here is B and G. So this answers the question of A union B complement. Okay, now let's look at another important aspect of set theory. That is set of values. I know that you are conversant with these same symbols: greater than or equal to, less than or equal to. Now, I want you to notice something. You can have something like this in your set theory or questions, where you have set A is equal to members of X, and X is greater, less, or equal to 0. Now, I want to note one key thing. The moment you see less than, look at this sign, less than or equal to, which means that this side there will be a dotted line, 1, 2, 3, comma, showing that numbers, values that are coming down to minus sign are supposed to be there if you have this sign this way. Then, but if it's the other way around, this way, greater than, then the dotted line, dotted point will be at the end, showing that greater numbers are supposed to be there. You know, this side is minus, so going this way is going positive, higher. So if you have greater than, just notice that the dotted line, the missing numbers will be at the back, not in the front. So let's get back to this. A is a set of S, and S is greater than or equal to 0. Now since S is less than or equal to 0, less than, I can start with minus 5, I can start with minus 7, I can start with minus 6, minus anything. But the key thing is that you must put the dotted line here to show that there are other lower numbers that can occupy this place. So in this case, I began with minus 5, so I have minus 5, minus 4, minus 3, minus 2, minus 1. Observe that I stop at 0. Why I stop at 0? Because it says less than or equal to 0. So you have to interpret it before you can find the set. Like after this now, you cannot be able to solve any question that was given to you. Now, they say that B is a set of S, and S is greater than or equal to 3. B. So this is greater than, that means I will start from 3. Greater number 4, 5, 6, and I have dotted lines. Greater than. Then the next one is C is equal to S, and S, remember the set of S, and S is less than 6. That means 6 will not appear there at all. Less than 6. 6 will not appear there. So that means C is, 6 is less than, remember the sign, less than. I will start with dotted line. I have 0, 1, 2, 3. Oh, sorry. I missed the number here. 4, and then 5. And the last but not the least is D. D is S. S is greater than minus 2. That means D. Greater than means that means I have numbers at the positive side. So I can, since I have greater than minus 2, greater, that means minus 2 will not appear at all. Minus 1 is greater than minus 2. So I start with minus 1, 0, 1, 2, 3. And then to let you that there are other numbers that are greater than minus 2. Now when you do this interpretation properly, you cannot be able to carry out any calculation that may come your way.